Hi guys, we're back in the workshop today, and what we're going to do is chapter 6 in our series on cutting steel. This will be the last chapter in this particular series, not particularly because they're the only 6 ways you can cut steel, but more to the point that they're the ones that would say a beginner in a workshop or somebody starting out fabrication or whatever will come across. There are numerous other methods of cutting steel. Oxy-fuel, which covers oxyacetylene, oxypropane, there's laser jet, water jet, and many others. But the 6 that we've covered thus far are the ones that we'll say are accessible to a guy setting up. Now, as I said, today we're going to look at plasma cutting. And a number of years back, this was sort of a very exotic type of piece of equipment. But of late, they've become very commonly available. And I noticed there recently enough that little a German supermarket chain were selling plasma cutters for about 129 euros, which is about $145 or thereabouts. So they've got to the point now where they're particularly accessible, and they have a number of very big advantages over other steel cutting. For example, if you're cutting steel plate, let's say an 8 foot by 4 foot sheet or 2.5 meters by 1.5 meters, very difficult to cut that straight with an angle grinder. You can't put it in a chop saw, etc, etc. So this is where these machines come into their own, is cutting long lengths of stuff. They're reasonably clean. There's a bit of sparks and a bit of dross come off them, but nothing near the dust that you'll generate with an angle grinder. Now, the advantage is that they're very quick, and you can cut long lengths quite straightforwardly with them. The downside to them is that they need a compressed air supply. So that sort of reduces their portability or mobility. Some of the sort of more upmarket machines, some of them do have built-in air compressors on them, so everything is sitting inside the one unit. But for, we say, the home shop owner, they're probably out of a reasonable price point at that point. So you're looking at using an air compressor with them. So there is a complication there. Also, you actually need a power source as well, so you need to run cables of a fairly heavy duty nature, especially to the slightly bigger machines. Now, before we move on to actually looking at the plasma cutter itself, just a few words on air compressors and air supply for a plasma cutter. Generally speaking, we say all plasma cutters will have a requirement for a particular volume of air to be sustained to cut. This could be measured in cubic meters or cubic feet per minute, or whatever the time is. So to a degree, the bigger the compressor you have, the better. But that does not preclude you from cutting with a much smaller compressor. This one here is a 200 litre unit with a maintained pressure there, peak pressure of 150 psi, which is about 10 and a little bit bars. You can use a small compressor, but what I'd recommend is that you do shortcuts, stop, allow the compressor to build up pressure again, and then continue along that basis. In addition, you must control the maximum air pressure into your plasma cutter. My plasma cutter requires air pressure at 90 psi, and it specifies that the maximum psi that you should let inside the machine, or input into the machine, is, I think, is 135 psi. Above that, and the little filtration units inside them have a tendency to blow. So look at the spec of your machine and adjust your air pressure accordingly. And I'll just move the camera over now, and I'll just show you a little regulator that you can get. Some compressors come with their own regulators where you can adjust the actual pressure in the tank. This one doesn't. So what I have is a separate regulator then to bring down the air pressure to go into the back of the plasma cutter. Now, what I've done here is I've connected this regulator up to my compressor, and I had that set for just slightly over 90 psi there on the clock. And effectively what we do now is we just plug in an extension line into that, ready for plugging into the back of the plasma cutter. Now, once I was gone there, I downloaded some of the manual for this particular plasma cutter. You can see it there. Right, and you can always pause if you want to have a read of that. But effectively what it says here is gas supply for the PowerMax 45 can be shop compressed or cylinder compressed. High pressure regulator must be used on either type of supply and must be capable of delivering gas to the filter on the power supply at 170 litres a minute at 6.2 bar, which is 360 cubic feet per hour at 90 psi. So that's where I'm getting my 90 psi setting there. And then further down it says do not allow the gas supply pressure to exceed 9.3 bar, 135 psi. The filter bowl may explode if this pressure is exceeded. So you can see there that there's some care and attention needed just to set up your gas supply. Okay, what we'll do now is we'll move the camera around and we'll just start having a look at the plasma cutter itself. And then after that, then we'll move on to the torch, okay? Now we're at the rear of the machine here, and what I have here is the air supply line that I just plugged into my regulator. This is the main power cord for the machine. It came recommended with a 32 amp supply. So what we'll do now is just demonstrate that power switch back here, air input here, and then the power supply going out there. Every machine will obviously be different, but you just might be able to get some familiarity by seeing this particular one. Now, this is the front of our machine. This is the cutting torch, and that's where that plugs in. And the other end of it is this fella here, and we'll go through the torch specifically in a minute. The other cable here is the material clamp. This is our workpiece clamp, clamped onto that small wire. It doesn't require a huge gauge. This piece clamps onto the material that you're cutting, but not the piece that you're cutting off. It's the bit that's remaining. Because what will happen there is, if you have this clamped to the piece that you're cutting off, when you come to the end of the cut, this falls on the ground and then exposes the possibility of a stray arc or something that you don't want. So leave this clamped to the piece that's clamped to the table or that you're leaving behind. Now, on the front of the machine then, what we have is an amperage button. Now, generally speaking, we'll say this stays at 45 amps. It is possible in this machine, although it's a 45 amp machine, to put in 30 amp consumables if you're cutting very light gauge material, in which case then you'd obviously turn down the amperage then to the 30. To the very left of that there, to the most counterclockwise position, is a gas test position, whereby just as you're setting up the machine, and we'll go through this in a while, you turn that, and what that does then is it illuminates little LEDs here, and there's a button on top of the machine, a little regulator screw to adjust the volume of air, either higher or lower depending. Okay, now this button here then, and not all machines will have this capability. There's three settings here. One is, the bottom one is arc gouging, it's called. The middle one is solid material cutting, and the one at the top then has a pile of little broken lines in it where the little picture of the torch is, and that's for cutting something like expanded metal or gratings or anything where there's a constant stop start of the arc. What it does is it maintains the ability to generate a high frequency current to restart the arc ignition when it stops after coming off a particular point. Generally speaking though, what we use is, or the one that you use most of the time, is the solid material cutting. I go through the difference between solid material cutting and gouging when I come to the torch, but we'll say for the two top ones, which is the expanded metal, or call it intermittent cutting, and solid material cutting, there's one set of consumables that go on the torch. And then for the gouging, which is like basically ploughing out metal out of a plate or whatever, there's another different set of consumables, so you have to keep an eye on that. Then along the top here, there's a number of indicator lights telling you whether you have AC power, whether your torch is connected properly, over temperature, and then you might get a fault on one of these as well, and then you'd refer back to your handbook. Okay. Now that we've gone through our compressor side of operations and our machine as well, what we're looking at now is the torch. The torches, they're quite pricey as a component of the machine. They do take a bit of abuse, especially with heat and slag hitting them. And as you can see with this one, it's showing a few signs of wear. Now, the way the torches are set up is the first bit on it here is called the shield. And this is, I'll try to hold it up now so you can see it. Right, that's a drag shield, and that's designed to be actually in contact with the material as you're moving the torch across it. There are some other torches which are standoff torches, and what you have to do there is you have to maintain a gap of about 2 millimeters. So if you are buying a plasma cutter, very, very useful to get one with a drag torch or drag torch consumables available for it. It just gets you away from that having to maintain a 2 millimeter gap, which is difficult when you're trying to get across a big piece of material. Right, that's the shield. Next bit then is the retainer, and what the retainer does is it keeps all the other bits in here. Okay, so off that comes there, and all that is just basically a holding cap with a thread on one end to hold these bits in. I'll go through these now in a second, and then another thread on the other side to hold the shield. Right, the next bit then is the nozzle, and this is where the arc extends from. Okay, so it should blow out through the little tip of the nozzle there, through the shield onto the workpiece. So the object is to try and keep these good. Next piece then is called a swirl ring, and in the middle of that then, and I'll drop it, this is just to direct the flow of air from the torch down onto the workpiece in as tight a form as possible. The last bit then, and sort of the business end of the whole show, is this. This is an electrode, and you can see there that there's windings on that, effectively like a thread. And what that does is it directs the airflow around in a particular pattern, and that airflow is what wipes away the swarf or the cut material out of the cut that you're making. And then the rest of the torch is just attached to the torch itself. Now, as regards consumables, in this particular instance, I can buy a pack of these, and there's a number of different. I'll try and do this now without throwing the whole lot out the desk. But as you can see there, like I have a full range of a spare swirl ring, a spare retainer, a shield, a number of nozzles, and then a number of electrodes. Generally speaking, what they say is that the consumables, and generally the consumables that you'd be concerned with, are the electrodes, the nozzles, and the shield. That you have about 1 to 2 hours of arc time on those. And just for example's sake, or for illustration's sake, this is the shield for gouging, and you can see there that the hole on that, or the outlet on that, is much bigger than the one for cutting. The whole object is that when you're cutting, you're trying to maintain a very tight, controlled arc, and then when you're gouging, what you're looking for is a big wide one to blow material out. Okay. Now we're set up with our plasma cutter, and what we've done is we've connected the air. You can probably hear that hissing in the background there. Our work clamp is set up here on the bench. I couldn't get it onto the two pieces of material, but we'll try it with the bench. Now this is 13/32 or 10 mil piece of rusty steel, and this here is 25 mil or 1 inch again mild steel. And we'll say when you're buying a machine, what you'll have to look for is 3 different numbers as regards cutting capacity. There's a recommended cutting capacity, and in this particular instance now we have a 45 amp machine, and the recommended cutting capacity of that is 12.7 millimeters, which is half an inch. Then it says that the maximum clean cut capacity is 19.1 millimeters, which is 3/4 of an inch. And then a severance capacity is 1 inch. So the difference between those is that when you're running along sort of half-inch plate, you can maintain a proper speed, get a nice clean cut. If your consumables are good, your air supply is good, etc, etc. With 3/4 inch stuff, you can achieve it, but everything needs to be working in your favour. And then when it comes to the severance cut of 1 inch, that's just basically parting material. It does not leave a clean cut. So what we'll do now is we'll just run through the first piece here. And generally speaking, the airflow out of the torch runs counterclockwise, and that means that the cut to this side here will be cleaner than the cut to this side because it's blowing the swarf or the dross out to the left. So if we cut this way, right to left, and we've set up a guide there, that should leave the piece that's behind on the bench cleaner than the piece that's going to fall off. That is a particularly prevalent or important to remember if you're cutting out a hole in a piece of material and you want either the piece that you cut out or the piece that you're leaving behind to be the cleaner of the two. Okay, so here we'll just give this a go now and see how it goes. Actually, sorry, one last thing now before we go. When we're cutting, right, what we're looking at, right, is the torch should be at a 90-degree angle there, and the sparks coming out should be just roughly somewhere between 15 to 30 degrees going that way. The logic being that if the sparks are cutting straight down, or sorry, the sparks are going straight down out of the cut, you're going too slow, and what you're doing is making a bigger cut than you need to. And then if the sparks are heading that way, sort of horizontal with your plane of material, you're cutting way too fast and you're not actually getting through the material, which will be ragged. Now, another point to note as well is these are fairly smooth pieces of material here. Make sure that your material is reasonably bump free, because as you're running along, if you hit a bump, it slows you down, and then that particular piece of slow travel then will open up your cut. Okay. Again, if your travel is too slow, what will happen is as you're traveling along, there'll be a bit of dross pop up and it'll catch the back of the shield, the cutting shield, and what you'll get then is a bumpy cut as you're going along. So keep your speed up, and we'll say keep an eye on the sparks underneath as well. Okay, so away we go now. We'll give this a go. Okay, this is take 2 on this. When I started the last time, I could get the pilot arc to light, but then the actual arc proper wouldn't light. So what I've done is I've reclamped directly onto my workpiece and then just jiggle it around there to get a better earth. Okay, so here we go again. Now, when you're finished cutting with the torch, you'll hear the air flowing through it still. The object of the air flowing through it after you finish cutting is to cool the tip down. Now, on the piece that I was cutting there, you can see I didn't get off to a good start and it was a bit lumpy. But then as I increased my travel speed, it improved then after that. Now, there is the temptation there, obviously, to cut again. But what we'll do this time is actually just knock it off and see how we finished up. Okay. Now, right, looking at that now, that's a good clean cut. The bit that's left behind, you'll actually see there's a bevel in it. So that's the bit that's the off cut. But generally speaking, we'll say that's not a bad cut there now, even though it did get off to a bit of a bumpy start there. But don't worry about that, you can always clean things up with a grinder. But you can see there that a good consistent travel speed is particularly important, and keep the speed up as well to make sure that your sparks are coming out in the right spot. Now we're set up with our second piece of steel, which is inch thick. Obviously this is going to be much more difficult to cut, and the best we're going to do is sort of a dirty severance cut, so to speak. But we'll give it a go just to demonstrate what's possible with a plasma cutter. Now we're on to attempt 3 to cut through the inch thick piece of steel, or 25 millimeters. What I've done this time now is I've changed out the consumables on the on the torch. The main reason was I think the nozzle inside was slightly sort of worn out or burnt out. So we'll give this a go now and see how we get on, okay? Now, typical, just as I was finished, the compressor came on looking for to recharge. Now, as you can see there, the changing of the consumables, the nozzle in particular, meant a much more direct and focused cut, which got us through the material much more successfully. Now, I'm going to try and pick this up and just show you the offcut. And as you'll see there's a sort of a significant bevel as it's going down. Now the other side of it isn't too bad. You'd reasonably, you're within reason, you'd probably straighten that out with a good grinder, but it just shows you the advantage of having good consumables and good nozzles and everything inside in your torch, that it cut through that there with no bother. That's about it.